So this is an implementation on a smart parking system under the category Smart City, and it uses an Arduino Uno as the main microcontroller, which houses the programs to control the LCD, buzzer, and ultrasonic sensor, and also the 3 indicator LEDs. So the LED is connected to the Arduino in a way such that the first pin, the ground pin, is connected to the Arduino ground pin. The VCC or power pin is connected to the Arduino 5V pin. The VO or contrast pin is connected to a potentiometer, which is connected to the Arduino ground and 5V pin to control the contrast. The register select is connected to the Arduino digital pin 13. Enable is connected to Arduino digital pin 12, and DB4 to DB7 are connected to digital pin 8, 9, 10, 11 respectively. And then LED anode is connected to the 5V Arduino pin, where the LED cathode is connected to a potentiometer, which is connected to the Arduino 5V and ground pin respectively. And then for the ultrasonic sensor, the ground is grounded to the Arduino ground pin, and the VCC power is connected to the 5V Arduino pin. The trigger pin is connected to the Arduino digital 2 pin, whereas the echo pin is connected to the digital Arduino 3 pin. As for the buzzer is grounded to the Arduino ground pin, whereas for the positive terminal, it's connected to a resistor to limit the current, and it's connected to the Arduino digital 4 pin. For the 3 LEDs, in this case, we're using 3 different LEDs to display 3 different scenarios. The red LED is connected to the Arduino digital 7 pin. The green LED is connected to the Arduino digital 6 pin, and finally the blue LED is connected to the digital Arduino 5 pin, all 3 of which are connected to a resistor to limit current, and the cathode is grounded to the Arduino ground pin. As for the code, the system starts with initialization of the pins, and then there's a function or subroutine called read distance, where it triggers the trig pin to low and then delays for a 5 microsecond before triggering it to high, and then delaying it to another 10 microseconds before triggering it to low. And then it will calculate the duration using pulse-in, and then it uses the formula duration times 0.0344 divided by 2 to calculate the distance. It then returns the distance to the main function, where it can accurately determine the distance of an object. So let's continue with the loop. So there are 3 scenarios. Let's say when the distance between the ultrasonic sensor is above 100 centimeters, then the green LED will light up whilst the blue and red are turned off, and the LCD will display parking available to indicate that the parking spot is available or there is no occupancy on the parking spot, and this can help the user to find a parking spot faster. Whereas if the distance is between 115 to 110 cm, the blue LED will blink and the buzzer will turn on to a 550 Hz tone, and the LCD will display parking spot is about to be occupied. So this will alert the user that a parking spot is about to be occupied, so they need to find for a different parking spot. So this parking spot is potentially reserved since a car is starting to park there. And if the distance is below 100 centimeters, the red LED will turn on, whereas the green and blue LED will turn off. There is no buzzer as well, but the LCD will display parking occupied to indicate to users that the parking spot is currently occupied and there is no parking spot available there.